Welcome back to Heartbeat Insights, everyone. Today we're diving into a really crucial area of cardiovascular health. Strokes are a huge concern globally, and often they're linked to issues in our carotid arteries. We're talking about preventing those devastating events, and specifically a procedure called carotid artery stenting. With me today, as always, is the brilliant Prof. Mansoor. Professor, thanks for joining us.
It's always a pleasure, Salma, and you've hit on a really important point. Carotid artery disease, where plaque builds up in those main arteries supplying blood to the brain, is a silent threat. When that plaque becomes unstable or breaks off, it can cause a stroke. Carotid stenting is one of the key tools we have to prevent that from happening.
Absolutely, and it sounds like a straightforward solution, no one about what to do. Also say. You put a stent in, open up the artery, blood flows freely. But I understand there's a delicate balance here, a risk we need to manage even during the procedure itself. We're talking about embolization, right?
Precisely. It's one of the primary concerns during the process of deploying a stent, especially when we're expanding it against a hardened plaque. Tiny bits of that plaque or even blood clots can break away. These fragments are called emboli, and if they travel up to the brain, they can cause a stroke right there on the operating table or shortly after. That's why we use protective devices like embolic filters to try and catch them.
So the goal is to prevent these bits from escaping. And what's really interesting is that this isn't just about the skill of the surgeon, but it could also be influenced by the design of the stent itself. Is that what this new study suggests?
Exactly. This study conducted in an Italian medical institution really zeroes in on that. They wanted to evaluate if the actual design of the carotid stent, how it's constructed, the pattern of its mesh, influences the amount of these stray particles or emboli that are released and caught by our filters. It's a critical question because minimizing embolization means minimizing stroke risk during the procedure.
That makes so much sense. We always think about the device's function, but its physical properties down to the mesh pattern can have such an impact. Could you tell us a bit more about the different types of stents they looked at?
Of course, the study focused on three main categories of carotid stents. First, we have what are called open cell stents or OCS. Think of them as having a more flexible, perhaps looser mesh structure. They're good for navigating tortuous or winding arteries because of their flexibility. Then there are closed cell stents or CCS. These have a tighter, more rigid mesh, offering more plaque coverage and potentially a more uniform vessel wall apposition. They might be less flexible, but they offer great structural support.
So OCS for flexibility, CCS for coverage and support, two different approaches. And the third one I heard about micromesh stents or MMS, that sounds intriguing.
Indeed, micromesh stents or MMS are the third category and in many ways represent a newer generation. As the name suggests, they have an incredibly fine mesh, much denser than either open cell or closed cell designs. The idea is that this ultra-fine mesh provides superior coverage of the plaque, potentially caging it more effectively and preventing those smaller particles from breaking off and escaping during the procedure.
So it's all about that caging effect, stopping those tiny bits from getting out. So this study looked at how well each of these designs did in preventing that escape. Who were the patients involved and how did they go about collecting this data?
Good question. It was a retrospective study, meaning they looked back at existing patient data. They included patients who had asymptomatic carotid stenosis, meaning they had significant narrowing of the carotid artery over 70%, but hadn't yet experienced any stroke symptoms. These patients underwent carotid artery stenting at that Italian institution between 2010 and 2022. So it's a significant time frame covering over a decade of procedures.
A long period, which means a lot of data, potentially making the findings quite robust. And how did they measure this risk of embolization? What was their primary focus?
Their primary endpoint was a very specific and innovative measure called the embolic filter debris, EFD load. Essentially, during these procedures, we deploy a tiny filter beyond the narrowed artery to catch any material that might break off. What the researchers did was to meticulously analyze the material caught in these filters after the procedure. The EFD load is essentially the ratio of the particulate material they found on the filter to the total area of the filter itself. So a higher EFD load means more debris, more embolization risk.
Wow, so they're literally looking at the smoking gun, the actual bits that broke off. That's incredibly direct evidence. And what about secondary outcomes? What else were they tracking?
Beyond the EFD load, which is a very direct measure of what's happening during the procedure, they also looked at the more traditional clinical outcomes. Specifically, they monitored the 30-day major stroke and death rates. These are crucial because ultimately our goal is to prevent adverse clinical events for the patient.
Right, because while the filter debris tells you about the micro events, the stroke and death rates tell you about the macro events, the actual patient impact. So they had a solid approach. How many patients were ultimately included in this study, and what did they find regarding the usage of these different stent types?
They analyzed data from 481 carotid artery stentings. That's a substantial number, giving the study good statistical power. In terms of stent usage, it was quite interesting. About 35% of these procedures used open cell stents, 14% used closed cell stents, and a significant portion, actually 50%, utilized the micromesh stents. So it appears the micromesh design is quite popular in that particular institution.
That's a really good distribution to study, especially with half of the procedures using MMS. So let's get to the exciting part, the results. What did they actually discover about the embolization risk and these different stent designs?
This is where it gets really compelling. First, on the secondary endpoints, which is good news across the board. The overall 30-day mortality and major stroke rate was remarkably low, at just 0.2%. That speaks to the safety and efficacy of carotid stenting in general when performed in experienced hands.
That's fantastic news, honestly. A 0.2% major stroke and death rate is incredibly low for such a delicate procedure. It reassures you about the overall benefit. But the main focus was on the filter debris, right?
Exactly. And here's the kicker. The use of micromesh stents, the MMS, resulted in the cleanest filters. A remarkable 41% of the filters used with MMS were found to be completely free from any embolized material. And across the board, the MMS had a significantly lower EFD load compared to both the open cell and closed cell stent designs.
41% completely free. That's almost half. And lower EFD load overall. That's a pretty strong indicator, isn't it, that the micromesh design is doing a better job at containing that plaque?
It certainly suggests that it aligns with the theoretical benefit of that denser, finer mesh. The researchers also made sure to adjust for other factors that could influence embolization, like the characteristics of the plaque itself, whether it was particularly soft or calcified. And even after making those adjustments, the findings remained consistent. Micromesh stents still showed superior performance in terms of lower EFD load.
That consistency, even after adjusting for plaque characteristics, makes the findings even more powerful. It suggests it's not just about the type of plaque, but truly about the stent design. So what's the big takeaway, the overall conclusion from this study?
In conclusion, the study strongly suggests that micromesh stents are associated with a lessened embolization risk during carotid artery stenting. This is evidenced by two key findings: fewer filters containing particulate matter and a lower overall embolic filter debris load. It really highlights the potential advantage of this specific stent design in terms of procedural safety.
Lesser risk of embolization means a lesser risk of intraprocedural stroke, which is a huge win for patient safety. But you know, Professor, with medical research, there's always the but or the however. What are the limitations or the next steps from here?
You're absolutely right, Salma. No single study, especially a retrospective one, provides the final word. The authors themselves acknowledge this. They emphasize that while their findings are compelling, further studies will be necessary to confirm these results. Ideally, we'd want to see larger, prospective, randomized control trials comparing these stent designs directly. This would help us solidify these observations.
So basically, more research to really nail it down. But if these findings are consistently replicated, what could this mean for clinical practice? How might it change how doctors choose stents?
It could significantly guide the choice of stent design. If micromesh stents consistently demonstrate a lower embolization risk, it could become the preferred stent type for many patients, particularly those with more vulnerable plaques where the risk of debris breaking off is higher. It would provide physicians with an evidence-based rationale to select a specific stent design, potentially leading to even safer procedures and better patient outcomes in the long run.
Absolutely. That's a powerful implication. Tailoring the technology to improve safety. It's not just about getting the job done, but getting it done with the absolute lowest risk possible. So while we await those future studies, this research certainly gives us a strong hint about the potential benefits of micromesh stents.
Precisely. It's a stepping stone. It opens up important avenues for further investigation and ultimately for refining our approaches to prevent strokes, which is, after all, the ultimate goal. Every incremental improvement in safety and efficacy is a win for our patients.
Absolutely. And it just goes to show how much intricate detail goes into modern medicine, even down to the mesh of a tiny stent. Thank you so much, Prof. Mansoor, for breaking down this fascinating and incredibly important research for us today. It's truly enlightening.
My pleasure, Salma. Always a good discussion.
And to our listeners, thank you for tuning in to Heartbeat Insights. We hope this discussion shed some light on the ongoing advancements in cardiovascular care and the critical role that research plays in improving patient outcomes. We'll catch you next time.